This conference will now be recorded.
Hi guys, good evening. Yes, can you hear me? Hello, can you hear me? Yes, guys, can you hear me? Anyone please respond? Can you hear me? Yes, no response, no one. Can you hear me? Hello. Yeah, thank you. Thank you for response. Yes, we'll start session. Yes, today topic is methods. About methods. Working with methods. So what is methods? Method like a C language function. In C language, calling as function. In Java, calling as methods. So what is method? Method is a set of statements. For example, main is a method. In main method, we are writing some programming, right? In main method, writing some programming. It's a method. Method starting, ending. It can some statements. Method can some statements. Method is a set of statements. Method is a set of statement to perform some task. Okay. Yes. How to define a method? Defining a method. Yes, defining a method. Yes, how to define a method in Java here. Defining a method. Syntax. Defining methods for the syntax. Syntax. Method syntax like this. First, return type of the methods. Return type. Yes, next methods. Name. Method name. See. First, 1 second. First, access. Access. Yes, specifier. Access. Specifier. Access specifier. Next, return type of the methods. Next, method name. Yes, next, data type. Type of argument 1, comma. Yes, type of argument 2. Yes, type of argument 3. Like this. Like this, number of arguments. Okay. Yes, closing. Methods, open bracket, close bracket. Correct. Next, method starting point, ending point. Open brace, close brace. Open brace, close brace. Now here some statements. First statement. Yes, next statement. Yes, next statement. Next statement. Next statement like this. There are some statements here. First statement. Next statement. Next statement. Next statement. Next statement. Thus, there are some statements like this. Okay. Next here say using some return keywords. Yes, return some value. This is method syntax. Syntax of method is like this. Access specifier. Access specifier. Next return type. Next method name. Yes, type of argument 1. Type of argument like this. Arguments. Open brace, close brace. Return some value. So this is syntax of method. Syntax of defining method is like this. Okay, defining method like this. Okay, the defining. Next, how to calling method. Calling a method. Yes, calling a method. How to call a method here. Method calling. Just using method name. Just calling methods using method name. Yes, by passing param 1. Okay, like param 1. Yes, param 2 by passing parameters. Semicolon. Suppose, for example, public access is for public. For example, access is for public. Okay. Next, return type. Suppose return value. Yes, the return type depends on return value. Return type depends on return value. Return value. Okay, say okay. Sorry. Yes. 1 second. So return value. Returning value. Suppose let us say 10. Returning 10. Returning 10, right? Yes. Access is where. Access is where is public. There are different access spheres. All the access spheres will see next. So public, at this stage I'm using public. Next, how to use other type of access space, we'll see next. Next, return type. This return type depends on return value. No, returning 10 means it's integer. Return type is int. Return type is int. Return type is int. Next, method name. Method name. Suppose method name is, for example, suppose add numbers. Add numbers, for example, here. Add numbers. Okay. Open bracket. Open bracket here. Yes. Next, method name here. Next type of argument 1, argument 2. Suppose arguments integer, comma integer x. First value x. Next integer y. Okay. Open bracket. This is for example here. So this is way of defining methods. Public, yes, it's an access sphere. Next, it's return type. Okay, so return 10 means integer. Suppose no value returning, it's a void. If no value, suppose if not like this, no value returning, it's a void. Yes, we'll discuss. Wait, I'll explain. Name of the method is some add numbers. Now there are two arguments. X first argument, next y second argument. Now this is defining a method. Defining method like this. Okay. Yes, how to call it. Is a method definition. It's a definition. Next, calling a method. How to call a method? Calling a method. Calling a method. How to call a method here? Yes, method calling. Calling methods. Yes, calling methods. Yes, add numbers by passing 10, 2 parameters. So 10 pass into x, 20 pass into y. This is method calling. Okay, this x and y call as arguments. 10 and 20 call as parameters. Parameter arguments both are not same. Different. I'll explain. Wait. Still topic is there. So this is defining Java methods. This is calling a methods. Okay. Fine. Yes. Now this. There are different types of methods. Different types of methods. Okay. There are different types of methods. Yet there are 4 types of methods. 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 First one, yes, methods. Methods with no written value. Yes, one second. Method with no argument. One second. Method with no arguments. No arguments. Method with no arguments and no written value. No written value. Method with no arguments and no written value. So first one, no arguments, no written value. No arguments, no written value. Great. Second one, method with arguments and no written value. Second one, method with arguments and no written value. Next, third one, method with arguments, unwritten value. Next, fourth type, yes, methods with no arguments, unwritten value. That's it. Unwritten value. Okay, right? See, the combinations no arguments, yes, no written value. Both are no. Yes, next, second case. Yes, arguments, yes, no written value. Arguments, yes, but no written value. Yes, third type. Yes, arguments, yes, next, written value, yes. Both are yes. Next, fourth one, no arguments, no, and yes. That combinations. See, both are no here, both are yes. Next here, one is yes, another one no. First one no, second one yes. That's it. The different combinations. There are different types of methods. Now let us start with method with no arguments, no written value. Method with no arguments, no written value. Method with no arguments, no written value. Let us see. See main method. Okay. No arguments, no written value. Suppose here public, white, this is display. Display methods. Public white display. Yes, open bracket, close brackets. Okay, that's it. Okay. Yes, public white display, no arguments. Yes, no written value. System dot out dot println. Yes, I'm in display. System dot out dot println. I'm in display. Yes, I am in display. Okay, I'm in display. System dot out dot println. I'm in display. Right? Now the defining method. See, this is main method, this display. Now display method, now calling from main. Yes, in main method, system dot out dot println. Yes, here main starts. Main starts. Yes, after that. Now I'm calling display method. Here's a display calling. Display calling. System dot out dot println. Yes, main end. Main end. Main end, right? Now here display method defined here. Define even defined is error message showing. What's the reason here? Yes, the static just appears here. Yes, that error solved. Why is static we have to place? The topic later we'll discuss. Okay, later we'll discuss. This is not a stage to explain about it. In OOPS concept, we have the static access modifier. That time we'll discuss. Static is an access modifier. Okay, see, main method is static method. Okay, so display is invoking from the main methods. Since it's invoking from the static method, this also must be static. Static method can make a call to only static methods. Static method can make a call to only static methods. That reason we'll discuss later. This is not right time to discuss. Okay, in OOPS concept, I'll explain it here. Okay, fine. Now, how this is working here? See, first main start displaying this message. Let's yes, display calling display control jumps to display methods. Control jumps to display here. Next part, I'm in display. Once you completed back to main here, yes, main end. That's it. So first starting main method here, main starts. Yes, not display calling. Control jumps to display. Control goes to display. I'm in display. After back to next statement. Okay. See, main starts, not display. Control goes to control jumping to display. Then execution of display. Once display completed, control come out of display back to next statement. Then main end. So the working of this. Okay. See, run it. Yes. Okay. So main starts. I'm in display main end. Yes. How method stack is working now? We'll discuss about method stack. Okay. 1 second. Display methods. Let us define one more method. One more method. Yes. Public white. Suppose show methods. Public white show methods. Show methods. Yes. System dot out dot println. Yes. I'm in show. I'm in show. I'm in show methods. I'm in show. I'm in show, right? Okay. Yes. So main starts. Yes. Display. Yes. System dot out dot println. After display. You see after display. After display. After display. Next here, I'm calling show methods. Just invoking show methods. Show. Yes. Error message. Then make it static. Show is static. Static. Yes. See, main method is static. Static method can make a call to only static methods. Static method can make a call to only static methods. So both are static. Show. Calling show. Okay. Fine. Next here. Okay. Now how it's working here? Yes. Let us see about stack. How the stack is working. Method stack is working. Okay. See. Yes, in memory map. Yes. Stepwise. Topic wise memory map. Yes. Okay. Now this memory map says. Yes, about stack we discussed. All the local variables stored inside of stack. That point already discussed. Next, heap memory, runtime memory. So yesterday complete topic is yesterday, day before yesterday we have discussed about stack and heap. Okay. New always working heap memory. Variable storing inside of stack memory. That's okay, fine. Now this topic method area. See, text area are program instructions, right? Now this topic on method area we should discuss. These two things we should discuss. Okay. Now get tested dot class. So for this program whole program converts into dot class file. Dot class file. This complete program instructions, all the program instructions, all these dot class program instructions simply yes storing at this location, loading at this location. Now this kind is all program instructions. Yes, how it's working? Let us see. The text area. Now let us take text. This is text area. Support text area. Text area. Let us. This is text area. Text area. Text area. This is text area. One second. Yeah, this is text area. Yes, all the program statements loads in the text area. Here, this is your program, and these are all our program instructions. Okay, program. They are program instructions, right? So program instructions. Program instructions. All the program instructions load in text memory, the text area. Initially, dot class and program instructions loads in text memory. After that, what is next step? What happens here? So first of loading, first start with main method, calling main method. So whenever main method calling here, that main method copy creates. Copy these are actual program instructions. From this, whenever calling main methods, that copy creates. Main copy creates. After creating main copy, what happens next step here? After creating main copy, okay, let me take another one. Next page. Yes, after creating main copy, yes, after creating copy of main method, that main method loads into method area. Here now it's a method area. So first main method loads into method area. Now this is method area. Nothing but method stack, method area or method stack. So main method loading, right? Main method loading. Now stack is like this. Yes, at the bottom of the stack, main method. Now this is stack. This is stack. Okay, right? This is main method stack. So this is main method stack is like this. One second. So this is main method. Okay, so main method stack is like this. No. First call to main method whenever calling. Yes, first JVM makes a call to main method. So whenever invoking main method here, for this main copy creates. The JVM creates the copy of the main method, then loading into the stack. This is called method stack. We call it method area or method stack. Yes, method area, or method stack, or you can say stack here, method stack. Variable stack is different, method stack is different. This is method stack. Okay, see here, this is variable stack. This is variable stack. This is method stack. Method stack. Okay, so first loading main methods. Now main method starts. In main method here, what happens? Main started, right? So this statement emerges. Main starts. This statement executes. This statement executes. Once executed, that disappears. That removes from stack. So what is output here? Yes, main starts. One second. Yes, now what is output here? One second. So this is right. So system.out method starts. Yes. This one executes. Once execute, that removes from the stack area. So what is happening? What is output here? First, this statement executes. This statement executed. So what is output? Main starts. Main starts. After this, next, what happens here? Display calling, right? Display calling. So display calling. Whenever display calling, here the statement disappears. Yes, clearing from stack. Here, display calling. Not display. Whenever calling display, for display copy creates. Display copy creates. Now this copy creates. Yes, whenever calling a method copy creates, note that copy placing on top of this method stack. So here placing display. Placing display, right? Display placed. After that, not display execution starts. Display. He enters in display. So now this statement. Next, this statement executes. Once executed, it removes. Once executed, removes here. So next, this one, right? This statement executes. I'm in display. I'm in display. Yes, after this, what happens here? Yes, this is completed up to this, right? Display completed. So this stack up to this completed, up to this completed. After next what system.out.println after display. Now this statement executed. Once this one executed, the statement also clears from stack. Clears from stack here. So this statement. So this statement, right? Now this statement working here. So this is right. This is after display. Okay, after that here. See like this from the stack one by one statement removing. Now show calling, right? So whenever show calling here, no copy of show creates. On top of it, copy of show creates. On top of it, copy of show methods. So whenever show method calling here, copy of show method creates. Copy. It copies into stack. Placing on top of stack here. Placed here, right? On top of stack. Placed. After that, what is stack? Last in, first out. This is last in, right? So it's a first out. Last in, first out. Stack is last in, first out, right? Last in, first out. That means now show method this will execute. Execute. Now this statement executed, right? Once executed, that disappears from stack. That removes from the stack here. So next statement is this, right? Next is this. Okay. Yes. After that, next brace, closing brace. Next is completed. Next what? This is statement. Finally, this statement. Now this statement executes. Main end. Main end. Now main end. Finally, main end, right? Main end. So here it's a main end. So this one, right? Yes. After that, next control comes out of this, right? Once comes out, this method is non-method stack is empty. Method stack becomes empty. Yes. No statements means program completed. Once method stack becomes empty, program stops. No statements method stack, program completed. That's it. Program stops. Okay. Suppose if any statements are there, the statements will execute, but no statements. It has become clear. It has clear, right? No memory, no statements. All are clear. Okay. Yes. 1 second. Yeah, Sandeep, method is called from places. Separate copy. Yes. Every time of calling method, it gets separate copy. See, this is original copy. See here, this is actual copy. This is actual copy. This is actual copy. This is actual copy. This actual copy will not remove. This actual copy will not remove. Okay, this actual copy will not remove here. Whenever calling a method, that copy creates. That copy loads into method stack. Method stack, method area, both are same. See, in stack, there are two types of stacks here. Variable stack, method stack. This is variable stack and method stack. Variable stack, method stack. Okay. See here, this is called as variable stack. This is variable stack. This is method stack. Method area, stack area, both are same. But stacks, there are two types of stacks. Variable stack and method stack. So method stack. On top of it, one by one placing. Method stack. So one by one placing, right? Yes, in this here, what happens here? This yes, this is original text. This is original text, right? This original text never removes. Okay. Yes, at the time of calling, copy creates, that copy loads into method area. Okay, suppose main method calling here, that main method loads into stack memory. Then execution starts. So whenever calling display here, display loads in stack memory. Whenever calling show method, that loads in stack memory. Okay, loading the stack, yes, last in, first out. Loading the stack and executing from the top. Okay, see, first the main method loaded, right? What happens? Main method execution starts. Main starts. Now display calling. What happens here? On top of main, now display placing, right? Display placed. What happens? Display will execute. Last in, first out. Last in, first out. That's it here. Okay. Suppose next show method calling. Show method calling, right? Show method calling. Now copy of show method calling here. Copy of show method creates and placing top of that main stack. Okay, right? Yes. See. Okay. So this is method stack or method area. Okay. So first calling main methods. Okay, this is where this is main means text. This is text memory. This memory called text memory. This is called text area. Text area. Text area. See your program. This is text memory. Text area contains program instructions. Text area contains all the program instructions. Is a text area. Text area, method area, or method stack. Anyone you can say method area or method stack or method stack. Method stack. Method area or method stack, both are same. Okay, now here text area. This is total dot class. This total dot class file. In dot class, text array is one part. The text array contains all program instructions. Text array contains all program instructions. Suppose let us say this is text area. For example, this is text area. Text area. In this all program and top to bottom all the instructions. The class test, main methods, display and show. Display and show, right? Okay. Yes. Now here. Yes. How it's work? First calling main methods. 1 second. Let me execute this program. Right click, run as Java application. See what is output here. Main starts. See. Yes. 1 second. Let me copy this one. Let us compare this. See main starts. See the main start, right? So main starts for the statement. For the statement, this is output. Okay, this is output, right? Next, I am in display. For the statements, yeah, this output. Okay, this output. Next, for the statements, this output. Yes, output, right? For the statements, this is output. This output, right? Yes. Next, for the statements, this is output. That's it. That is the working of stack is like this. Okay. Yes, I'll explain. Just wait. The stack I will explain once again. Now, here how this program is working here. First starting main method. So first output main starts. Next display calling. Control jumping to display methods. In this I am in display. Once display completed, control back to that calling method. See in this display method is calling from the main method. So main is a calling method, display is a called method. Calling methods and called methods. Okay. See display is calling by the main, right? Display calling from the main. So main is a calling. Yes, it's a calling method. This is calling method. It's a calling method. Not display called by main, right? So it's a called. This is called method. This is called method. This is called method. This is called method. Calling method, called method is like this. Suppose for example here, show calling from the display. What happens? Now this case. Now between these two here, between these two, display and show, right? Between these two here, between these two here, display is a calling method. Now display is a calling method. Yes, between display and show here, display is the calling method. What is show? It's a called method. Okay. Yes. Now display, yes, it's calling show method. So display is the calling method. What is show? It's a called method. So between two methods, display is a calling method. Show is a called method. Next, between main method and display here. So main is a calling method, display is a called method. Okay, fine. Now main starts of displaying here. Display, control goes to display. I am in display. Yes, after finishing this one here, now control back to where calling method again, back to calling method. Okay, once method completed, control back to calling method again. Okay, any method completed here, control back to calling method. What's the calling method? Main method. So next statement is after display. After that next show calling. Now control jumping to show methods. Control switching to show methods. I'm in show. Once you completed, now control back to same calling location. That calling method. So next main end. So what is output here? First main starts. Display calling, control go to display. I am in display. Next back to main method. After display. Next show calling, control goes to show method here. I am in show here. After this back to main here. Main end. That's it here. That's it output here. Okay, run it. Main starts. I am in display. Next after display, I am in show. Main end. That's it. Okay. Yes. Now let us see about stack operation. How stack is working. So first, JVM makes equal to main method. Whenever calling main method, copy creates. Copy of this main method creates. Now this is text area. This text area contains that all the program instructions. It's this version of copy of instructions. From that here, so first the main method copy creates. Whenever calling main, copy creates. That copy loads into stack memory, method stack. So this is called a method stack here. So loading into method stack. This is method stack. Okay. One second. Method stack, main method loading. First of all, loading main method. Main method loading, right? Yes, main method loaded. So this is, yes, main method stack. Yes, sorry, method stack. Main method loaded. Main method loaded. Okay. So main method loaded. First, whenever calling method here, copy creates, that copy loads in the stack memory. That copy always loads in stack memory. Method stack loaded. What is stack? Last in first. Now main method loaded. After this, now starting main method. This statements invoking, so that removes. Next, this statement executed. One statement executed that removes from the stack area. Removes. Statement executed removes. So main starts. One second. So main starts. That statement executes. Once a statement executes, that removes from the stack. Not display column. Display column, the statement executed, right? Statement executed. Whenever display calling, what happens here? On top of the statements, on top of this one here, now placing display copy of this. Whenever calling a method, it creates copy. For display, copy creates. For display, copy creates, not this display. This copy creates. After creating copy, this copy loads into that method stack. Method stack. Now on top of it, display. Display on top of it, display place, right? Now which one executes here? Last in first out. Stack is last in first. What is last in? Yes, display is the last in. Display is the last in. Display is the last in first out. Last in first out. Last in first out. Okay, display is last in, right? Yes, what is stack? From the top removing. Stack always remove from the top. So this removes. Okay, now this statement executes. I am in display. That statement removes. That statement removes here. Means that statement executes. Once a statement executed, that removes from the stack. Once a statement executes, suppose this statement execution is completed, that removes from the stack, removes. So means method completed. Okay, method completed. After this, what is next statement? This is next statement. In stack, see, try to observe stack. In stack, next statement, what this is next statement after display. So that removes. Now after display executes, right? After display. Yes, next after this, no show calling. Show calling, right? So this statement executed. Once executed, that statement removes. Show calling. No show method on top of it. No show method calling means calling. That means show copy creates. Copy of show method creates. Copy creating. Copy creating again loading into stack. That copy creates. That copy loads in stack memory. Loads in the stack memory. So that copy loads in stack memory. Loaded. Loads in stack memory. Okay. After loading the stack memory, what happens here? Now again same concept. Last in first out. Now this is last in, recent in, right? Recent in, out, in, out, last in, first out. So this removes. Now this statement executes, right? Once this statement executed, this also removes from stack. Remove that stack here. Remove from, yes, a statement executed. Once executed, remove from stack. Remove from stack. Yes. After this, next completed. This is next. Yes. For understanding purpose, I am drawing line actually. Okay, it won't place any line separator here, just for understanding purpose. What is next statement? Pending statement is main entry. These are last statements. Pending statement is right. This statement executes. One statement executed, that disappears from stack. Removes from stack here. One statement executed, that removes from the stack area. Correct? So complete next. Close brackets. Close brace means control come out of this. Yes, that also removes. That also removes, right? Means now stack has become empty. So once the method stack becomes empty, plugin stops. Now method stack is no method in the, yes, no statements in method stack, right? It stops. Simply plugin stops. Okay, this is working of method stack. Method stack like this. Working of method stack is like this. Okay, yes. Now see what is output here. So main starts. Yes, I'm in display. After display, yes, I'm in show. Main end. Now let us run this program here. Run as Java application. Run as Java application. Okay, one second. Java application. So this output of the program. Outputs. Now let us compare this outputs. For the statement main starts. For the statement this output, right? Just matched. For this statement I mean display. For this statement this output matched. Yes, match rate. For the statement after display this is output here matched. For the statement I mean show. Yes, output match rate. Output matched. Main end. Main end, right? That's it. Yes, that is my explanation is match rate. That's it. Okay, so working of method stack is like this. Working of method stack is like this. Okay, yes. Now here, see how it's working here. Now, see come to here. First main starts, display calling, control goes to display. I am in display. Once display method completed, back to main after display. The reason based on stack it's working. Okay, next show calling, control go to show method. I am in show. After that, once the method is completed, control back to calling statements. The statements, main end. That's it. So first main start displaying here. Main starts, display, control goes to display, display method executes, back to main here, next statement this is. Yes, after that, show calling, control goes to show method. I mean show. Once it completed, back to yes, next statement, then main end executes. This is working of method stack. Method stack. One second. Yes, if method defined but not called, that case it won't create any copy. Why? Okay, it won't create any copy. So if not calling method, it won't create any copy. Okay, so for example here, yes, public void demo methods. Demo methods. I'm in demo. I'm in demo. Now run it. Will it run here? Demo methods. Yes, will it show output demo? I'm in demo has to show here. Let us check it. I'm in demo. Run as nowhere output I'm in demo, right? No, I'm in demo is not dispatch. Okay, is not dispatch. Means the stack is not created. So the demo method is not loading the stack. So whatever the method loading the stack, that stack executes. Okay, stack executes, not actual copy. Not actual copy executing. Executing stack always. Okay. Yeah, right. Sandeep, you are right. One copy will be storing in stack area always. The text memory. The text area that is for main, that is main copy. That main copy should not be removed. Main copy will be there. Main copy will be there. This main copy never removes. Never removes. I'll tell you. Yes, I'll tell you one more example for your question. Main copy never removes here. That copy will be there always. Suppose for example here, main starts. Yes, after display, main ends. Let us remove show method. No show method. Yes, only display here. Yes, display starts. Yes, here display starts. Display starts. Display starts. Half display starts. Yes, again I'm calling same method display. I'm calling display. Okay. Next what? Display end. Display end. Display end. Yes. How this is working? Let us see how it's working here. So first main start of displaying this message. Of displaying this message. 1 second. Now this one loads into text memory. This text. This whole thing loads in text memory. This whole thing loads in text memory. Now let us take text. This is let us take in text memory. Text memory. So text area. But text area. So main. Yes. After display. Yes. No show calling. Main start display off display main methods. Okay, main start off display main end. Okay, display. Yes, display starts. Yes, here's a display starts. Display starts. Yes, next here I'm calling same display again. Display. Display. Same display calling. Okay, right? Yes, after that display end. After this, next display end. Display end. This is a display end. Display end. Okay, display end, right? Next, don't have show methods. Fine. Now, how this is working? How this statement is working? Let us see. First, main copy creates. Copy creates. That copy loads into method area. Yes, main copy loads in method area, right? Loaded. After that starts. Main removing the statements. Main start executes. Next display calling. So whenever calling this method, here now copy of display creates. Copy of display. Now let us take copy of display method. So display copy. The display copy loads into this. Right? Loads in this, right? Yes, after that. Static where this one executes. Yes, display start here message. Not display calling again, right? Yes, display calling. Yes, where that method is available in actual copy. Display. Now again calling display, right? Means from where copying in actual memory in text area. Yes, again this copy creates. Again copy creates. I think Sandeep now it's clear. Okay. Yes, again display copy creates the display copy loading. So one copy always keeping instead of text area, always one copy keeping instead of text area, not display loading. Display loaded. Okay. Of loading display, what happens now? Again, last in first out, last in first out. This removes. Again, what is output? Display start. Again, display start output here. So display start. So again, display start output, right? Once again. Again, output display start. The display start output here. Display start output. Display start output. Okay. Yes. After this, next. Next. Again calling display. Again calling display. Right? What happens here? For this, yes, one more copy of display creates. One more copy creates. One more copy creates. So one more copy. So one more copy. So one more copy of display. Yes, the text in text memory, the instructions are there. Every time creating copy and loading to method stack. No loading into method stack. Loaded. Loaded, right? Of loading is one here. Of loading. Now again last in first out. So this statement executes. Next, again display starts. Again output is display starts. Again display starts. Again display start like this. Display starts. Okay, after that, now again display calling, right? Again display calling. So again display calling, right? So what happens whenever calling display here? Now again copy creates. Again copy creates. Okay, again copy. Again copy creates. Again copy creating. Correct? Yes. Again copy creating. Again copy creating. Again copy creating. What happens here? All the stack filled. Stack filled. What happens? Stack overflow exception. This one raises stack overflow exception. Stack filled already. No stack. Stack filled already here. Stack overflow. Now run this. See. First main starts. Display calling. Undergo display here. Display starts. Next display calling itself means it's called recursive methods. This method is called recursive methods. Display calling itself. Calling itself. So what's happening here? Continuously display start, display start, display start. Never goes to end, right? Never goes to end. Calling itself like a loop. Calling itself like a loop. So display calling itself, just the calling itself. Never go to the statement here only. Just the calling itself. What is output? Display start, display start, display start, display start, display start. For how many times? Still stack is available. Up to stack is available, then working. Once stack fill here, stack or error. No run it. Yes. See that? One second. Boom. See. Display start, display start. Always display start, right? Display start, display start. Display start. Display start, display start. One second. See display start, display start. Display start, right? Display start, display start. Continuously. Yes, see this. At this stage. Yes, at this stage. See display starts. Main java.lang stack overflow error. So recursive method chance of raising stack overflow exception. Here this statement, this kind of methods are called recursive methods. Recursive methods not at all recommended. In real time, the recursive method not at all recommended. Okay, chance of raising stack overflow exception. Okay, same statement repeatedly executing, right? Yes, scenario where you want to repeat same statements again and again here. Don't use recursive method. Better go for loop. Loop is the better. So better go for loop. Yes, in case of loop, it won't create stack. No worry. It won't create stack here. Okay. Yes, no worry about loop. But method means it will create stack. For method, it will create stack here. For method creating stack. For method creating stack here. Loop won't create stack here. Okay. So same method calling again and again. Stack overflow error. So recursive methods not recommended. Chance of raising stack overflow errors. That's it. Okay. Is it clear? So why stack overflow works like a infinite loop? Yeah, infinite loop, okay. Infinite loop, okay. But somewhere stopping, right? Infinite means what? Never ending. Infinite means never ending. But here ends, where it ends? When stack overflow. Whenever stack overflowing stops. Application fails. Application fails. Is it clear? Stack overflow. Stack overflow means application failed. Application failure case. Okay. There are many failure cases in applications. This is one kind of scenario here. Stack overflow error. Recursive methods. Recursive method chance of raising stack overflow errors. Stack overflow errors. So recursive method is not recommended. Not only here. In C language also recursive function not recommended. Stack overflow errors. Okay, C language, Java, anywhere stack overflow error raising here. Recursive function is not recommended. Okay, fine. Yes. So this is about recursive methods. Okay, recursive methods. Method calling itself is a recursive method. Okay, right? Yeah, this is about first type. What is first one? Method with no arguments, no written value. No arguments, no written value. First type this is. Method with no arguments, no written value. Next, second one. Method with arguments and no written value. Method with arguments, no written value. Let us see how this is working here. Yes, main starts, okay, not necessary. Suppose int a equal to 10. Okay, right? Next int b equal to 20. Okay. Yes, display calling. Yes, 1 second. 1 second. Display calling by passing a comma b. Okay. Now receiving here. For this int x comma int y. See, here we are passing two integers. These also must be integers. Yes, a is integer, so this must be integer. B is integer, this must be integer. Okay. Yes, after that, now. Yes, in display here, x and y. Displaying x value, x equal to plus x plus tab y is equal to plus y. Okay. Yes. Now how this is working? Let us see about this one here. How this is working here. So first main method. Yes, 1 second. I think maybe explain documents. Working with methods. 1 second. In document memory map explains. Yes, again drawing memory map maybe time is. Yes, working with methods. Method is a set of statement to perform some task. Yes, every statement of method should terminate semicolon. Syntax, same we discussed. Access is where return type depends on return value. Return 10 means integer. 10.5 means double. Okay. Yes. Yes. Suppose if no access is where mentioned here, it's a default access where. If not public here, without public cars working, no problem, no issue. But it's a default access where. It's a default. Suppose if it is like that kind of method you can't invoke from the outside. Yes, here main method is compulsory public, no doubt, because main is invoking from the outside. Main is invoking from the outside. Display public is not necessary. Okay. Default is not no. Default is not private. See, it's working. It's working. Default is not private. Default is default only. Okay. Public protected, default, and private. There are four types of access requests. Default is different, private is different. We'll discuss wait. This is not right time to discuss. I'll explain after finishing OOPS concept. In OOPS concept, I'll explain wait. After finishing inheritance, that access request you can understand. Here at this stage I'm using public. At this stage simply I'm using public. At this stage just using public. Okay. Yes. Now this is method with arguments and no written value. Now this x and y called as arguments. Arguments. A and B are the parameters. See, A and B pass into x and y, right? A value pass into x. X is a receiver. B value receiving by y. These receivers are called as arguments. Whatever the data we are passing, that is called parameter. Parameter. So these are parameters we are passing. What are the data we are passing? A and B passing. That means A and B are the parameters. Now we get x and y arguments. X and y arguments. Okay. 1 second. I'll tell you one practical example. Yes, sir. That's arguments and parameters. For better understanding, arguments, parameters. CD test. Okay. Dir Java test. Hello Java world. What are these things? Parameters. Command line parameters concepts means we are passing whatever data we are passing. This is called parameters. Hello Java world. These are the parameters we are passing. So whatever data we are passing, that is parameter. Now this is receiving where main method string square back aux. See that it's aux. Yeah, that is called aux. Yes, that's it. Yes, why named as aux? That is called argument. Yes, don't say parameter. This is not parameter, it's argument. This is called argument here. It's aux. Okay. Whatever data we are passing called as parameter. These are parameter. The three parameters passing to area of aux. That's it. Now int xy, these are arguments. A and B are the parameters. Argument and parameter both are not same. Many are says that both are same. No, wrong. What are the values you are passing? Those are called as parameters. Receivers are arguments. Okay, parameters and arguments difference is that. Okay. Yes. Now let us come to your yes. See different types of methods. That four types of methods. That list given. Method with no arguments, no written value. That example. That examples. Examples. Yes. Next. Method with no arguments, no written value. Yes. Now. Yes. Example to explain about method stack. This is stack. Stack area. Method stack. That copy main methods. Stack. So this is. See this is text area with main program instructions. Okay. Next. This is method stack. Okay. Yes. Recursive methods. Display. Calling issue. See method area. What happens here? What happens? See this. Display ends on top of the second display ends here under calling recursively. Calling recursively, right? Calling recursively. Stack growing like rates. Reaching this. Yes, reaching top. Yes, stack overflow exception is. Recursive methods not recommended. There is a chance of raising stack overflow exception. Very clearly explained documents. Yes, my document is like a spoon feeding. Okay. No need of writing any running notes. Just follow documents. Okay. Yes. Yes, suppose if I'm giving running notes, if I'm giving notes, what happens? Wasting of time. Wasting of time. Document prepared. Okay. Suppose simply I'm giving notes means same topics will be taking for 4 months. That will take for almost more than 50% of time we can save it. Okay. See, many of the trainers, they will give us notes. It's a time pass class. Giving notes to students is a time pass class. I don't want to time pass my class. I want to utilize this maximum. Okay. No time pass class. Every minute, just I want it to utilize for you. So that for that reason, I have prepared documents I'm sharing with you. Next, one more thing here. What are the documents sharing by the trainers? They will not share. I'm sharing my document. Yes, my document may be circulating anywhere. No problem, no issue for me. Not an issue. Because no one is complete with me. I feel like that. Okay, no one is in market. No one is competition with me. Okay, even they have my complete recordings. Even they have complete my documents. They are not complete for me. Because my way of explaining is different. Their way of explaining is different. Okay, 100% that is sure. Okay, I have that much of depth in subjects. Now, let us come to this topic here. Yes. Now here this is, yes. Now this program. Method with parameters or arguments, no written value. Okay, see. Now how it's working here. First, the control enters in the main methods. Whenever control enter main methods, variable A and B memory allocating for A and B. Where this is in variable stack. Yes, variable stack. A and B. Memory allocating for A and B. After that, what is output? Main start. Main start. Output is main start. After that, no display calling, right? So calling display. So whenever calling display, what happens here? Control jumping to display methods. Control jumping to display methods by passing these values. A value, yes, passing to X. B value passing to Y. Now what happens here? Display. Display copy creates, right? Where that copy in method stack. In method stack, display copy creates. Okay. Now display arguments X and Y, right? For X and Y, local stack creates. Instead of methods, this local stack creates. Local stack. In method, some local stack creates. In that local stack, X value is 10, Y value is 20. X is 10. So A value pass into X, B value pass into Y. Local, yes, you have to imagine this type of memory here. When you using arguments here, the data. So for X, local memory creates. For Y, local memory creates. So that A value pass into this local memory, B value pass into this local memory. You have to imagine this memory. Then you can understand anything here. Just try to imagine this local memory. So this 10, A value, A and B, A and B. See, this A and B in main method. Now these values as is passing to its local copies. See, same data here in main method local copies, same data in display copies, right? That's it. Local copy. I am in display. I am in display. After arguments are yes, X value, Y value. What is X value? 10. What is Y value? 20. 20. After that, what happens after executing the statement here? Control come out of display. Once the control come out of display here, loss of this X and Y, loss of local stack, because the stack removing rate, that method is removed from the stack, so the local stack also removes. That variable disappear. X and Y clears. Back to main, right? Back to main. Next after display. Next before show. Next show method calling. Show method calling, right? Now control jumping to show methods. Okay, here 50 and 60 are parameters. Now control jumping to show method. Control simply goes to show methods. Sorry, simply control jumping to show methods. Okay, control just jumping to show methods. Control switch to show methods. Switching, right? Because that copy created. Now control goes to show methods. What are 50 and 60? 50 and 60 passing to show methods. For show method, this local copy creates. X and Y local copy creates. X and Y. What is X value? 50. What is value of Y here? It's a 60. 60. So 50, 60 passing. So this 50, 60. After I mean show. Yes, arguments are X and Y here. 50 and 60 displaying here. Half displaying. Next, the control come out of method. Control comes out of method, right? Once it comes out of this method here, loss of this X, loss of this Y. So these are local variables. Local variables. Okay. Local copies, loss of local copy. Back to main. Back to main, right? Back to main. Suppose in main here, after show, suppose after this, suppose again I'm calling display, what happens here? Again I'm calling display here, what happens here? Now, for display, one more copy creates, right? One more copy creates. One more copy creates. Yes. Now control jumping to display. Now again control jumping to display, right? Now again for x and y copy creates. Control jumping to display here. Now for x local copy creates. For x just creating local copy. Just will create some local copy here. Just local copy creates. Just like this. Local copies creates. Yes, again local copy like this. Again that again second time calling here. Second time. Yes, 1 second. Second time local copy creates. The local copies. For x and y local copies creates, right? After creating local copies, what happens here? Yes, we are calling display after show here. Calling display by passing 100 comma 200. Now what happens when you are calling display here? Yes, the method loads in stack memory here. The stack area, yes, x. Again that copies creates. Again copy creates. Then 100 pass into this x. Next 200 pass into y. That's it. After that, displaying x and y, right? Next control come out of this. Once you come out of this, loss of this memory again here. Okay. See, these method arguments are local variables, local values, local copies creates. Method arguments always local variables, local copies creates. Okay. Yes. Once you control at the time of control entering the method here, at the time of entering into methods, these variables acquires memory. These local copies acquires memory. Once you control come out of method, loss of these variables. That's it. Method arguments are local variables, local copies creates. Once execution is completed, once method completed, loss of that local copies. That's it. How that method arguments are working is like this. Okay. Yes, I think everyone you understand, right? Yes, method with the arguments no written value. I hope everyone you understand. Okay. So this working of method with arguments no written value here. See what happens here whenever calling display. Yes, a pass in the x. So for x local copy creates. B value pass in y. For y local copy creates. Okay. So a value pass into x memory. B value pass in y memory. Displaying x and y. After control come out of this method. Once you come out of this method, loss of these variables. Method arguments are local variables. Method arguments are local variables. So once you control come out of method, loss of that variables. Okay, at the time of entering into control, sorry, at the time of entering into methods, this memory allocates for x and y. Okay, see, at the time of entering into methods, these two variables acquire arguments acquires memory, and using that arguments, once a control come out of this method, here, loss of this x and y. That's it here. So a value pass into x, so local copy. B value pass into y, local copy. That's it. Now run it, run as. See this? Yes, x equal to 10, y equal to 10. That's it. Okay. So a value passed to x, so 10. B value passed to y, it's a 20. That's it. That's it. Suppose. Now here some question for you guys. Int x equal to suppose 50. 50. Yes. Now this statement int x equal 50. This is valid or not? See, I'm declaring int x equal 50. Yes, valid or not? Yes, if you say yes or no, then I'll use semicolon. Suppose if I say semicolon, if I'm closing semicolon, Eclipse shows. Eclipse shows is it valid or not? Suppose if valid means no error. Okay, valid means no error. Okay, if not valid, error message. No, I'm not closing semicolon. Suppose if I put semicolon, Eclipse gives the answer. That case, you need not give the answer. Eclipse gives the answer. No, I'm not closing. I'm not putting semicolon. Okay, with semicolon valid. Suppose if semicolon valid, see error message. Error message. Yes, x equal 50. It's error message. Semicolon error message. Reason. See x duplicate local variable. This already x is local variable. This x is already local variable. X is already local. Already local. Again we are declaring means duplicate variable declaring. We are declaring duplicate variable. It's duplicate variable. So this error message duplicate means duplicate local variables. All this that means this is a local, right? See, what is message? Duplicate variable. Duplicate local variable x means already one local variable is there, right? Duplicate variable local x. Duplicate local variable x. That means already one more variable is there. That means they are local variables. That's it. Now the error meaning is what here? This x is local variable. Okay. So method arguments are local variables. Method arguments are local variables. Okay. By the same name, we can't declare one more variable. Okay. One more is a duplicate variable. Suppose if I remove int, what happens? It's working now. Now what does mean? What happens here? Tell me. What happens? Suppose x equal 50. What happens? Executes okay. What happens? Executes okay. See, a value 10 passed the x. X. What is x? Initially x contains what? 10. X contains 10. X contains 10, right? Now x equal 50 means this 50 overwriting on this x here. Okay, x contains what? 10 initially. 10 passed to x. So x is initialized with this 10, right? Now if I say x equal 50, this 10 overwrites. What is x value? Say 50. X value is now 50 here. It's assignment overwriting. See, x is 50. Okay. So if not, then x value what? 10. It's a 10. It's a 10. That's it. Okay. So what happens here? Overwriting. That x value overwriting. Yes, like this are still, if you want like this, you can use like this here. Int x comma x equal to, yes, you can change its values, you can change it, no problem, no issue. Okay, its values x equal to 50, yes, y equal to some 40 like this. You can change that values, no problem. Okay, that method argument values you can change it, no problem, no issue. Initially 10 and 20. Now overwriting 50, overwriting 40, overwritten. After overwriting, now what is output here? Next time output 50 and 40. 50 and 40. Okay, so this is method with arguments but no written value. Method with arguments, no written value. Okay, fine. Next, other types. Method with arguments, written value. Next, method with no arguments, written value. Next, call by value, call by reference. Call by value, call by reference. The topic we should discuss. Tomorrow we'll continue that here. Call by value, call by reference. What is call by value method? Call by value. What is call by value? Call by reference methods. Next, method with arguments and written value here. Method with no arguments and written value. These concepts tomorrow will continue. Right? Yeah. Any doubts? Yes, guys, any doubts? If no doubts, let us wind up session for today. Right? Yes, are you understanding clearly my topics, my way of explanation? Are you understanding clearly? Are you getting any confusion? See here, explaining in depth also dangerous. Yes, explaining in depth also somewhat dangerous, because some students may not be catching that. Their level may not be reaching. Okay, some students their level may not be reaching. That case, they will, what they feel, this trainer is not good, he is not explaining very clearly. You'll feel that I'm not understanding, he's a bad trainer, so why not choose another trainer? They will think like this. Okay, means they need basics. Okay, they need basics. Suppose if you learning basics, attending interview, never success. With basics, if you attending interview, never success, never getting success. That's the reason many students are learning Java, learning so many technologies, but not getting job. See, 70-80% of students are not getting jobs. Out of 100 members learning, out of 100 members, maybe 10 or 15 members only getting job, because their level in depth they are learning, they are facing interest, they are getting jobs. Who are thinking about basics, they're never getting jobs 100%. Okay, yes, you have to think in not in basic level. Okay, see, what I promised at the beginning, by the time of finishing course, you must be in a position to put up minimum 4 to 5 years of experience. Minimum 4 to 5 years of experience. That's the reason I'm explaining in depth of concepts like this. Okay. Yeah, interview questions are like, I'll give you. In document interview questions are there. In document interview questions are there. Let's go through the questions here. Even, yes, I'm asking some questions in class, right? In class itself, I'm asking some questions. Okay. Just see the document. In document interview questions are there. Still, I'll explain. Some interview questions I'll explain. Don't worry. Right? Yeah. So that's all for today. So thank you guys. Yes. See you tomorrow. See you tomorrow. Okay. Right.